to give you a little bit of a background, as we said, our hackathon, which occurred over the summer, we had a team of 4 judges, and we were evaluating all the team, and actually 2 teams ended up tying for first place. So it had the exact same score. So instead of having a first and second, we had dual first place winners. The first one we're going to kick off, Brian, this was a team that combined a local startup, XReps, with the University of Nebraska Medical Center. And so with XR medical procedure, Brian, take it away. And I will say, as he's finishing setup, the presentations will be about 6 minutes, and then we'll have 2 or 3 minutes for questions. I don't know, do we have it shared online?
I don't see it shared.
Is it shared?
No, it's not shared.
Not shared. Hybrid meetings are always a challenge a little bit, so got to get both sides of it working correctly.
And share everything. Yeah, sit there. They're perfect.
Looking good. Great. Well, hello, I'm Brian. I'm with XR Medical Procedures, powered by Haptic Labs. Thrilled to be here today, and I want to first give a quick shout out to Jim Starka and Aaron Deacon of KC Digital Drive, our presenting fellow presenters, and our sponsor, T-Mobile, fantastic, Kaufman Foundation, Intel, 1623 Barnum, and UPN for this amazing event. So let's just go ahead and dive right in. What's the big idea? Well, our mission is to create a mixed reality surgical experience by using augmented, virtual, and extended reality to simulate the sense of touch, sound, and motion, i.e. haptics. Students, professionals alike can gain that real-world experience with an understanding of a procedure without having to practice on a living patient. So here's our team. It's XReps coming in force as our 3 musketeers of devs, Joel Stevens, Sonny Stark, and Josh Hangster. We reached out to UNMC's IXL as our medical and simulation subject matter expert. Greg Elliott from 1623 Farm is our project manager, keeping us all on track. And I'm Brian Pittahart with Down to Fold, gamifying experiences through digital and analog transformations. So fairly new for myself to the XR procedure. We wanted to check what the current state is, and so we knocked on the door at UNMC's IXL. We took a look and walked through some pain points, success stories, shortcomings of existing solutions, and how our approach we think is better. Fortunately for most of us, if not all of us in the room, we have an interest in extended reality, AR or VR. From gaming to cinema to training, XR is here. It's notable to see the growing adoption of XR. More so, there are now studies that show compelling evidence of cognitive benefits of XR training. And this with multiple methods of haptics currently used in other applications, we feel is equally important to our mission. And on the flip side, current training that's out there right now, well, it's not fully immersive and it's just expensive. So here's a look at some of the things that are out there right now in the training space. Photo on the left, you'll see a glove, and then while integrated, it's not fully immersive. The middle photo shows a VR experience, and it's just not quite happening. And lastly, the current products out there, albeit beautiful, they're very cost prohibitive. Who is our competitors? We took a look, we found that ASO VR is in that range with the virtual reality medical training. They don't have any haptics right now, but maybe they're working towards that. Augmetics, well, they're focused on spine procedures right now. It's not to say they can't go into knee surgeries, but that's where they're at. And, they do have some haptics, but not much. Fundamental surgery is a ton of training resources out there, but again, a limited array of haptic feedback and contrary to what we're focused and fully delivering. So how are we different and how are we going to succeed? We take an XR approach to solve that problem. In such, we create that fully immersive environment. Everything from visual, auditory, to sense of touch is simulated, while delivering that high fidelity sensory feedback from outside objects. And speaking of outside objects, we use the exact same medical tools currently used today. How cool is that? A perfect marriage of existing software and accessible hardware. What we're able to accomplish over the weekend could go easily beyond knee surgery and into a variety of medical procedures and non-medical applications alike. Speaking of future applications, I want to touch quickly on exploring spaces we're looking into in surgeries, including biopsies, C-sections, hernia surgeries, and more. We're also uniquely interested in developing a haptic lab score, an HLS, if you will. That it's a way to standardize the training and evaluations of students and professionals. How does it work? Well, the first half of Magic, we use Unreal Engine as our platform. We tested out using T-Mobile's 5G hotspot. Future state, we're looking to grow into AWS's analytics database and HIPAA servers, maybe even implementing Intel's depth and LiDAR technologies. And so hardware-wise, the other half of the Magic, we called up HTC's Vive headset with Steam VR pucks and Arduino sensors. So remember that medical equipment we was talking about? Yeah, so we have devices, those devices have been retrofitted with 3D printed drill bits and saws. We think that's pretty cool. And on top of it, we've cast a prosthetic knee that has full of receiving sensors to bring that immersion experience here and now. Well, enough talk. I'm going to give it over to Joel to answer your questions. He's got a demo set up in the next room. And Joel, if you want to come up here and maybe field a couple of questions, if anybody has any, and now's the time. Thank you very much, everybody. I don't answer, but Joel.
Is anybody using your product right now?
They're not. So no, this was totally greenfield from the hackathons. We took the challenge. We started out with XR as our, we do a little XR training in sports. So we took our knowledge there. We've done some hardware integration. We integrate to footballs and virtual reality training. So we kind of used those skills and brought it to medical training. So we're doing Steam VR tracking on the actual medical devices. We have an interactive knee, Arduino that senses tools being used against it and then gives it a little haptic feedback. So we're really trying to give that full 360 sensory experience in virtual reality.
You just answered that question for me, but so explain XR. You described it as XR.
Okay, yeah. So XR, it's many things to many people, I think. Some people say the X is for extended reality. Others say it's the X is a stand-in for AR, A, V, or M. So I think you chop, take your pick. So we say it's extended reality, so it extends reality into both virtual and physical.
What material did you settle on for the knee 3D print?
So we use 3D printed PLA.
Okay.
So, yeah.
Yeah. But I couldn't tell the color.
Is it pretty successful so far, though? Is it pretty, on the market?
So we've gotten some good feedback, people who've seen it. We've talked to the medical lab up in Nebraska, so they're kind of excited to see where we can take it. So they've been giving us a lot of feedback along the way. So yeah, we'll see where it goes. Yes, sir.
Now, how much of the software is yours, and how much of the software are you just blending from open source and the like?
So the Unreal Engine, we use some local, some of the assets. So we didn't develop all that in 2 days. So there are some marketplace assets. The knee and the patient. So that was all one of our tech artists put that together. The Arduino software, we picked a couple of sample projects that use, one of the things we have is a pressure sensor. So when you press the saw against the knee, we're detecting that pressure. So we found an Arduino project that had that built in, and so it's a little bit of a mismatch of different things. We use some of our the motion controller tech that we built at XReps as well. So kind of true hackathon. We hacked it all together, what we could find.
Any questions?
Do you see any limitations in your product?
Yeah, so limitations, I mean, it's, you know, it's hard to really simulate true reality. So, you know, we did bump up against some limitations we think, you know, that are going to be tough. So some procedures, it's going to be tough to track a large number of tools and equipment in the same space. So if you're doing scalpels and wipes and these kinds of things. So yeah, there's definitely some places we won't be able to take it. We can focus on procedures that use the major tools and are kind of well defined. We think we can do a pretty good job there.